Hello, everyone. Good morning. My name is Harpreet Singh. I'm alongside Santiago Gutierrez, Andrew Hu, and Kodai Yu, and we are BuildingCHEQ. So that the problem that I'm going to address today comes from this unprecedented notion that I'll explain in a minute that often leads to the unnecessary demolition of buildings, which has a lot of negative effects in terms of environmental, socioeconomic, and economic as well. Now, demolition of these older buildings in New York, they often cost a lot of money. So that's the economic factor, as they're between $70 to $120 per square foot. And we know that most buildings in New York are about 2 million to 4 million square feet. So older buildings, specifically ones constructed in pre-2000s, are deemed to be unsafe to use due to the establishment of the newer safety codes enforced throughout the past 10 years. And that's what causes this unnecessary demolition. Now, recently, a new set of building codes have been established in an attempt to meet a careful balance between minimum requirements for older buildings and a level of safety equivalent to newer buildings. However, there is not an accurate method to ensure which of these safety codes are met and which aren't, which makes it difficult to decide which buildings need to be demolished. As a matter of fact, preservation of these older buildings will result in more affordable housing, job growth, and the retention of high-quality pedestrian-oriented buildings as well. So now to pose our solution. As we know, there are millions of older buildings that don't have a reliable safety record due to the evolution of building codes that are present today in newer buildings. To resolve this issue, we developed a program, BuildingCHEQ, that allows a user to input his or her 2D floor plan and receive an output of which safety codes are complied, which ones are not complied, and what the individual must do to ensure the safety regulations are up to date.
As for similar technologies in the market, there really isn't something similar in the architectural space, but we can make a comparison to Google OCR. And this is where you can point your camera at a text and it'll translate it for you. Because in the end, both technologies, our program and Google OCR, take in an image, process it, and break down and find important characteristics. Another technology that is used in our program is edge detection, where it's a technique used to identify discontinuities within an image. And it's most notably used in medical imaging. So diving into our algorithm, this mostly takes place in Python, and we use packages in OpenCV, and we apply a form of edge detection called canny edge detection to identify edges. And from there, we have a really big challenge of taking in inputs from something as chaotic as a architectural drawing. Because if you consider something like reading a text off an image, the inputs are very orderly, but in a architectural drawing, the inputs are not. So to overcome this, we use a combination of template matching and point and click interaction to divide and conquer, to essentially segment our drawing. So here we have an example where we're trying to find the width of an aisle. So the user would draw like a box around the aisle that he's trying to measure. And then this little snippet of this main image is then going to be passed into our algorithm. And our algorithm will try to match a template of this aisle, which can be seen here. And from there, it'll make a one-to-one, attempt to make a one-to-one pixel comparison. And in the end, it will be able to identify where the hallway is exactly and the dimensions of it. So once these key features are identified, they are passed into a coordinate system. And using algebra and geometry and scale factor and such, we're able to convert between the pixel widths and the pixel lengths into real-life measurements. And here we applied the condition checking algorithm, which is essentially the translation of the safety building code from the architectural jargon into the compiler language. So we can automate this condition checking process. And here we have a list of conditions that our project checks.
So now we're going to start our program demo, which is for step 1. So we're going to start by the user input. In this step, the user will input their drawing. It could be in a PNG format. And then they will be tasked to complete some true or false questions, as well as some numerical ones about the drawing. The type of questions could be What is the number of seats? What type of occupancy is this? Well, depending on the user's answers to these questions, different tests are going to be applied to the dimensions collected on the drawing. Then step 2 involves some user interaction with the drawing. They will be tasked with selecting certain points in the drawing with the use of their mouse. Instructions to this will be found on top of the screen. These clicks will be translated into coordinates that will then be used along with other values obtained by the program to make calculations on different parameters needed. Then we're going to go to step 3. Now that the program has all the values that it needs, it will test all the conditions needed, and then the user gets a report in PDF format that goes over the sections of the building code. If the section passed, it will be highlighted in green, and if not, it will have a breakdown on which checkpoints the problem resides, along with a link to that specific section on the building code. Finally, in step 4, the user goes over the report and is able to click on the checkpoints that didn't pass, which takes them to that specific part of the app code website, which is a site containing building codes from different cities and states. This way, the user is able to find out why it didn't pass and take the necessary actions.
So we tested the functionality of a program through several blueprints, and a scale based on the standard door width of 3 feet would be used to convert the program coordinates to real-life distance. And the ideal test would have been to have an architect use our program to complete a building code check on a drawing, and then have the same architect perform the same procedure by hand, but we were unfortunately not able to due to time constraints. However, we know that it takes roughly 30 minutes to complete the most time-consuming portion of the building code, and our entire program takes roughly 10 minutes to complete. So even if the program is ran several times to check different areas of the design, we can say that our program is more efficient. And finally, we have determined that the dimensions retrieved from our program are extremely close to the actual image. And through this long-term project, we have realized that the implementation of large-scale algorithms require planning and strong understanding of programming. And as such, we experienced limitations where we were unable to create a user-friendly program as we wanted it to be. And also we had limitations with the amount of building code we can work with the limited manpower and time that was given to us. So for a conclusion, we have designed an algorithm that uses image process technology to automate the process of checking building codes by hand. And in doing so, our algorithm ensures that a building complies with safety standards and helps determine if old buildings can be repurposed instead of being demolished. Our work brings about impacts in several ways. First, economic. It gives less expense in the process of building construction, since we are reusing buildings instead of building a new building from scratch. And this leads to a social impact where affordable homes are available on the user end. And then finally, for environmental, reusing of old buildings means less construction material. So that's the end of our program presentation today. Thank you very much. And we're now open to any questions.